Are we ready? Good. I'm going to start. Thank you. Good afternoon, everybody. Welcome to Safe Buildings, a discussion on air and water quality and design strategies. I'm Georgie Ann Bailey. I'm the Executive Vice President of the New York State component of the American Institute of Architects. Now for a little bit of housekeeping. This presentation is protected by U.S. and international copyright laws. Reproduction, distribution, display, and use of the presentation without written permission of the speaker is prohibited. This program is registered with the American Institute of Architects Continuing Education Systems. It is registered for 1.5 LUs HSW. As such, it does not include content that may be deemed or constructed to constitute approval of any method, product, service, enterprise sponsorship, or endorsement by AIA New York State. And I do believe we have members on from New Jersey and Pennsylvania, and that covers those state components also. The statements expressed by speakers, panelists, and other participants reflect their own views and not necessarily reflect the views or positions of the AIA state components previously mentioned, local components of the AIA, or those of their respective officers, directors, members, employees, or any other organization associated with them involved in the planning and production of this program. Questions related to specific products and services may only be addressed at the conclusion of this presentation. And actually, that really doesn't even imply because we don't have any products or services that we are promoting or selling today. Disclaimer, this is a legal disclaimer. This webinar and associated materials are being provided for general educational purposes only. Information provided during this webinar and the materials should not be construed as professional advice. Participants should consult with their own licensed architect or other appropriate professional concerning the subject matter of this webinar, the materials and their application to any specific facts or circumstances. The statements of the webinar moderator and panelists are their own, and they are not statements of the AIA, New York State, Pennsylvania, or New Jersey. And up on the screen next, of course, are your learning objectives, which were provided to you at the time of registration. And I think with that, I'm going to turn this over to our moderator, Illya Azaroff. Illya is our New York State Disaster Assistance Coordinator. And I'm also very proud to tell you, he is the 2021 president of AIA New York State. Thank you, Illya.
Thanks, Georgie. It's really great to be here today, and I'm so glad we had a great response for all of you listening in today. Again, yes, my name is Illya Azaroff. I am an architect in Brooklyn, New York, leading a practice, and I also teach at the New York City College of Technology. And what Georgie put on the table is that I'm the New York State Disaster Coordinator, part of an entire national network of disaster coordinators that has been put in place by AI National. As many of you know, this current crisis poses circumstances and issues that we have never faced before in our lifetimes. And as with any crisis, this is an inflection point that following this crisis, the building industry and the AIA will need to respond in terms of how we make our communities safer, not just today, but for the long run. And we do this in service to society. So I'm really pleased with the panel today to really be able to hear their thoughts on some of the things that are going on. But it also must be said that, you know, our oath as architects to protect the health, safety, and welfare of the public is now needed more than ever. And it is our ethical charge to assist and volunteer after disasters. Go to the next slide, please. Next slide, please, Mike. So with that being said, our ethical charge, almost 15 weeks ago, we formed what's now called the AIA New York Unified Task Force City and State. And in those 15 weeks, we've done a lot of work. Our goal has been simple. It's to combine the efforts of the AIA components across the state of New York and in the city of New York to serve as an effective resource to the state and the city and all of our communities, not just during this crisis, but far into the future. We will continue that work with a great many volunteers that are already on board, along with our allied professionals. And I invite all of you that are on the call today and on the webinar, if you wish to join our efforts, please reach out to me personally or to the task force or your local component. We'd love to have your voice and ideas to really talk about what the future holds for us. And I'd also like to thank the work of the task force for these first 15 weeks. And although it's just the tip of the spear, as we should say, as we get to an effective place to keep assisting, I'd like to thank specifically Nick Rakovich and Daphne Binder, two of the leaders that have been doing such great work, and Nick in particular for assisting in forming today's panel. And with that, I'm going to introduce our panelists. Next slide, please. So first up today, I'd like to introduce Kevin, Dr. Kevin van den Melenberg. He's a professor from the University of Oregon in the Department of Architecture and currently serves as the director for the Institute of Health in the Built Environment, the Energy Studies in Buildings Laboratory, and the Biology and Built Environment Center. He will be followed by Dr. Molly Scanlon, and Molly is the Director of Standards and Compliance and Research for Phigenics. And she is also an AIA COVID-19 Task Force and Re-Occupancy Environmental Health Scientific and Public Health Advisor. Molly will be followed by Susan McClemens. Susan is an independent specification consultant, providing specifications and construction contracts consulting services to architects and organizations since 2001. She has over 30 years of experience in the preparation of specifications for a wide variety of project types. So with that, I'm going to turn it over to you, Kevin, and pass the screen over. And I'm looking forward to the question and answers at the end. Thank you very much.
Wonderful. Well, thanks to New York State AIA for the opportunity. I'm going to run through a few slides to try to kick us off here. First, I just want to say thanks to the team. Can't do any of this work alone. This is the team that has been helping to conduct this research that I'll share today. Go ahead and go to the next slide. The woman in blue and the gentleman next to her is Patrick and Leslie. They've been doing a lot of this work. I want to talk just briefly about the Institute for Health and the Built Environment. It's a really unique kind of collaboration between industry as well as academia. So multiple universities as well as several industry partners participate in this organization with labs at the university. Next slide. We've been busy since early March. In the first week of March, as we started to see the concern of coronavirus on our own shores, we launched into action and wrote a paper on reducing transmission risk that ended up getting a lot of traction and was hopefully useful to AIA and ASHRAE and other organizations as they were developing standards. We subsequently rewrote that paper 5 times over the last 3 months or so, with multiple preprints and then final 2 versions of the final paper. So I think links will be made available. We've also been monitoring coronavirus in built environments, specifically in healthcare settings, and then trying to turn this knowledge into actionable information for building operators and future designers, as well as general public, and help them understand the implications of viral transmission indoors. Next slide. I say that we've kind of, as a human species, we've moved from caves to spaceships. And for the last decade, we've been working on the microbiome of the indoor environment. And with funding from the Alfred P. Sloan Foundation, we now understand that there is a distinct indoor unseen microbial ecology. that we create, whether we know it or like it or intend it or not, with our architectural design as well as with our building operational decisions. We have microbial hitchhikers in our race for the sterile space, and we've lost some diversity in our human exposure as we disconnect from outdoor ecosystems. Buildings house trillions of microorganisms interacting with each other and with humans. Understanding the indoor microbiome opens a design opportunity to support human health in really unprecedented ways. And we knew that before COVID-19, and it's now in everybody's worldview and understanding. We've learned how building design and operations and human behavior shapes the indoor microbiome. And as Churchill said, something like, we shape our building microbiomes and thereafter they shape us. I think that's what he said. We know that exposure to sunlight, access to fresh air through operable windows, and material choices all impact the indoor microbial landscape, and human exposure to both beneficial as well as potentially pathogenic microbes. Next slide. In 2011, we took this idea of studying indoor microbiology to the Lillis Business Complex, and we were interested in this building for several reasons. There's a diversity of space types and activities that occur in this building, but also our energy lab. This was before I joined University of Oregon, but our energy lab had done consultation on this to try to reduce climate impact. And you know, for 2001, when this was constructed, it achieved an EY of less than 40 for a large higher ed building. That was pretty exciting. But here we find the synergy between health and energy coming back to study this building in some of those energy efficiency strategies with regards to the indoor microbial ecology. So you can see that these plots are actually kind of phylogenetic tree plots showing different indoor microbial structures with different room types and different air handlers, and some of that predicated by the activity. Here you can see different offices on different air handlers have different microbial signatures. And what you're seeing here is a microcosm kind of study where we did 3 days of operation, where we had some rooms that were mechanically ventilated and some rooms that were passively ventilated with the natural ventilation and night flush cooling strategy. And really what we were able to determine is that there was a reduced abundance of potential pathogens in the spaces that had natural ventilation. We don't know the mechanistic explanation precisely, but it could have to do with solution to pollution as dilution, or it could have to do with the lack of filtration and intentionally introducing a more diverse microbial ecosystem from the outdoors. Next slide. So when coronavirus became really urgent here in the United States, we took this microbiology knowledge from the last decade and we applied it to what was emerging rapidly in terms of this virus. And in particular, we put together this visualization, which ended up getting a lot of traction. CBS this morning and BBC World News picked it up. And really it was just explaining a very simple phenomenon. And for those in the architectural world, this was probably fairly intuitive. But for the general public, people had a hard time understanding the mixed messages around aerosolization and airborne transmission and the magic 6-foot circles. And so really what we tried to do here is just show how architectural design in conjunction with building operation really can make a difference for this virus as well as for other pathogens and, you know, more broadly in support of human health. So the next slide will show what we did in collaboration with Oregon Health and Sciences University. And I have to take my hat off to OHSU and their leadership team for accepting this really important responsibility to show leadership in the space of healthcare engineering and practices to promote safer healthcare environments. But really, this phenomenal opportunity is also generalizable to other building types, because if we can sample the spread, the fate and transport, if you will, or the spread and dispersal of coronavirus in hospital settings, there's a lot that we can learn about what's applicable to other building types. Next slide. So you can see what we sampled multiple locations in multiple rooms, including patient rooms and the OR. And this first image here is of one of the patient rooms. And again, I just want to thank OHSU for allowing me to share this publicly. This is vulnerable information in many ways, but I've been so impressed with their springing into action as we got these data 2 months ago now at this point. And they've been enacting new operational practices in real time with this feedback. So what we see here on the graph is a map of where we sampled in the physical environment in a hospital room. The blue box with the red dot is an example of a location within that room that was sampled positive for the RNA. Now, that doesn't necessarily mean that that was viable RNA and therefore infective, but still tracing RNA from SARS-CoV-2 or coronavirus in the hospital helps us understand a lot about potential transmission risks. Well, that blue box is the return air grill. And so that was my first clue that indeed coronavirus RNA is getting picked up into the airstreams and sucked into the exhaust stream of the hospital. The other red dot is the surface on the floor in the bathroom, which gave me clues about potential aerosolization events from toilet flushing. The other thing I want to add is this room had been empty and clean without a patient in it and without a coronavirus or a COVID positive patient in it for over 10 days. Then what we see here is another room. This is actually a negative pressure room. These rooms are designed to pull air from the rest of the hospital through this room, and this is where you put really sick people. In fact, this is where they're putting patients with coronavirus in negative pressure rooms. You can see, again, much greater abundance or presence around the room. And again, another empty and clean room where a patient hadn't been on that ward in over 10 days. And then finally, the third slide, oh, I'm sorry, I think maybe I forgot to say slides. So here, this is the second patient room, the negative pressure room. And then the next room is the operating room. And of course, the operating rooms in hospitals have the highest air change rate, highest filtration, et cetera. And the red dot in the corner was the only positive sample, which is really encouraging in many regards, because of course we want to keep the patient as safe as possible. But it also tells us a lot about where eddies and airflows really do implicate the potential fate and transport of this virus. That was a passive air settling dish, again, on the same day, which means there hadn't been a positive patient in the ward for 10 days and no positive patient had ever been in that room. So this gives us a clue that it's either floating around in aerosols or potentially being moved around on surfaces that move in and out of these rooms. Next slide.
Hey, Kevin, could you go back one slide? I'm sorry to interrupt you. There were two people on the chat that really wanted to see your middle slide just for a moment.
Oh, yeah, sure. So this one is the negative pressure room that we saw more locations that were positive. If you really want to dig in, the black circles are swab areas, so that where we took a surface swab, and the red circles without the solid fill are passive settling dishes. That's where the dust is just settling into a petri dish. So you can see, for example, in the bottom left corner, we swabbed the counter, it was positive, and we put a passive settling dish on the counter, and it was also positive. Next slide, and then actually you can skip 2 forward to the next kind of picture. Oh, this is you, New York. New York AIA needs the slide here, right?
Yeah, so this is your first slide for CEUs. There'll be multiple words throughout to understand and that to get your CEUs, you need each of these words. And Kevin, could you briefly mention what a negative pressure room is? That was one of the questions on the chat.
Sure. Yeah, negative pressure rooms are fairly common in healthcare settings where they are aware of the need for infection control. And so those are rooms where all the other air from the rest of the hospital theoretically is brought, I should say it differently. The intention of that room is to not let air from that room seep out into the hallway or into the other locations within the hospital. So if you have aerosolization events with COVID positive patients, they prioritize those things to occur inside of negative pressure rooms because those are exhausted without going back into the recirculated airstream. And they are negative in that the air from, when you open a door, the air should be sucking in to that room and then out the exhaust stream. So at less risk of transmission out to the hallway. Okay, next one. So as we look to the future, I think there are some things that we're already learning. We've done over 1,000 samples at OHSU now. We've been up there 10 times or so. You're just seeing the results from the very first trip there as we work through this process, and more will be coming out in publications. But really what we're looking for is building design as a way to support human health, as well as a way to minimize transmission risk. And so we're looking for those synergies. Daylight and sunlight can support healthy sleep-wake cycles, which can support human immune function and human immune robustness. And they can also degrade microbial ecosystems that maybe have unwanted pathogens. And of course, go ahead to the next slide, we'll unpack a few more. You know, there's a lot of discussion around filtration. Again, a really important strategy, but really what I want to impress upon this is there's no magic bullet. There are multiple layers, and we need to think both about kind of engineering controls like increased filtration, as well as opportunities to enhance and support human immune function. And that means both, you know, both of those hats are important. Thank you. Humidification is another concept because it has to do with particle deposition rate, as well as human immune function, as well as even there's evidence to show that that mid-range humidity can more quickly erode the lipid shell of the virus and inactivate the virus. Next. And then of course we have targeted strategies like, you know, UVC irradiation or UVGI, germicidal irradiation. There's more and more research being done on that in terms of how long does a room need to be exposed? What's 254 nanometers versus 222 nanometers, and what does that do to the virus versus the human? Next slide. Thinking about this notion where you have to have buildings that can be flexible to increase outside air exchange rate during a viral pandemic when you have an indoor source of contamination like a COVID positive occupant, or in cases where wildfire smoke or outdoor pollution is such that you need to do enhanced filtration and do more recirculation. And the scary thing is there are times when both of those are a reality. And so our buildings need to be flexible and dynamic to that. Next slide. We're working on concepts for real-time biological monitoring in indoor environments. We're at early stages, and I'd say that's a technology that I hope we can see come to reality in the next 6 months. Next slide. And then we're also working on solutions to more rapidly detect viruses in buildings just using our current manual methods. And so we've been working with university leadership to sample buildings at OHSU, and we're beginning the launch at University of Oregon as well, where we'll have this opportunity to get a near real time, like a day-by-day situational awareness of what the transmission risk might be. And I think this is hugely valuable because, for example, the South Korean call center had several days where people were infected in that building before the big spike occurred, as many as 7 to 10 days later. So if we could be detecting risk on a day-to-day basis, I think there's a lot we could use to make actionable improvements. Next slide. This is just to show that we're trying to scale this up and share this with other universities. I've had some conversations with Nick Ratkovic, who was mentioned earlier, about potential doing this work in collaboration through a mail-in system where samples can be collected and shipped to nearby labs for processing. And I'll just end on one final slide that says I'd say we're designing on a new frontier where we're dealing with a pandemic, a viral transmission, as well as a crisis in terms of climate change. It's a crisis within a crisis. And you know, new frontiers need new pioneers. So I hope to be able to help collaborate and work with all of you to make safer buildings in the future. Thank you.
Thanks, Kevin. This is our second word, bacteria. And that'll cue up Dr. Molly Scanlon.
Good afternoon, everyone. Thank you for having me. I'm going to be talking to you about 3 different areas. Next slide. So I actually have 3 different positions here, just to clarify, because I'll be going over 3 different areas. I do work in industry for a firm called Phigenics. We are a water safety, water quality firm that deals with waterborne pathogens, primarily in the United States and Canada, and have building overs across all building sectors. I am also an associate instructor at the University of Arizona and participate in the College of Public Health and Research. And I'm also an appointed member to the AIA's COVID-19 task force, both for the healthcare surge capacity, and I'm working with the disaster preparedness group on the Re-Occupancy. Both Kevin and I have been participating. So I'm going to be giving you snippets from all of those aspects. So next slide, P. I'm going to go over the water systems first. So there's a concept that I want everyone to understand here that's different than electricity with sustainability. So this is, I like to, with my colleagues here in the design community, we often exchange the words sustainability and efficiency as if they are equal. They are not. Water safety plus water efficiency has to be sustainable. If the water is not safe and you will be infected or killed by it, there's no point in having it be efficient. Building systems that drive efficiency of water to 0 actually are the most dangerous buildings. I spend a lot of time in the United States on doing LEED buildings for water efficiency because they are harming people. So it isn't just LEED, it's just that the practitioners, people are so dependent that water coming out of the faucet is stable, they believe that, and it is not true in all cases. Next slide, please. So with COVID-19, with the SARS-CoV-2, there's a comorbidity challenge. So this comorbidity is when there are 2 disease situations occurring in the human body. And so you've heard a lot about immunosuppression. So a COVID-19 patient, the ones at highest risk have an underlying disease or a complex condition, hypertension, diabetes, coronary heart disease. I happen to have restricted airways in my lungs from inhalation of secondhand smoke because my parents smoked in the 1970s and 80s. So I'm someone that could have an increased risk, even though I am totally appear healthy to other people. These are some of the things that they found in some of the early research from China. They also found from the city of Qingdao City that if you are a COVID-19 patient and you now have had that and come across another situation and your body is still in a compromised state, you may have the flu, another flu, or you may actually, there were 20% that were exposed to a waterborne pathogen and are deceased. And so when these things interact with each other in terms of disease structures, it can be lethal. Next slide, please. And go to the first bullet and next, bacteria. Go ahead and advance down through these and stop when it comes to the bottom. Thank you. So there are many bacterias in our water. Legionella and Legionnaire's disease is commonly talked about because it's the only US reportable disease locally, state, and up to the national CDC. The rest of these bacteria exist in water, but they're not the poster child. They're primarily they can be in any setting, but they infect and can create disease structures inside of immunocompromised patients. So we look at all of these various bacteria, protozoa. Fungi would be mold in water. You've heard about mold in building systems, I'm sure. And Aspergillus and Fusarium can exist in water. They're more common in Europe than they are in the United States. Under viruses, we typically have norovirus and hepatitis A, but we've listed the SARS-CoV-2. It can be in water. It's not in the supply water system at this time, as far as anybody knows. It's in the wastewater system. And so this is where we want to have a positive, we have a safe water system right now, and that's very important during a pandemic. It's very important that we haven't had floods or tornadoes or something else yet to compromise our water system so that people can have confidence in using that water system during a pandemic. Next slide, please. The other concern you can have is chemical hazards. So your water is safe up to the entry point from the US EPA up to the building edge. It is guaranteed to be safe. It is supposed to be free of lead and copper and other high chemical and metals. However, what brought to light during the Flint, Michigan situation was that service lines and other older buildings may have water that, with the right combination of things going into the water system, or if what's called stagnated water occurs, these metals can leach into the water supply and then end up being in the fixtures. So when you go back into a building, all of these buildings currently that have been shut down have to be completely flushed and evacuated of the water that's been sitting there for weeks or months. Typically, if the building's been sitting more than 30 days, it should be recommissioned for its water system. Next slide, please. So what I do on a daily basis is I'm working with building owners across the United States, and I implement water policy from the CDC, the US EPA, the American Water Works Association, and any state Department of Health. So at the end of the presentation, I did add one in for the New York City. They have a guidance for returning building water systems to service after prolonged shutdown. Many states are taking an opinion on this. And if you are working on a team or with engineers where something's going to happen, or you're going to be modifying fixtures or the water supply, you should be checking these out. So one of the biggest calls we're getting right now is from university campuses that have over 300, 500 buildings on them that have to be maintained or brought back into full use from low or no occupancy, and they have to purge all this water out of the system. So that's a very labor intensive process. And then there's testing, as Kevin's talking about. There would be environmental sampling that would occur to show that the water system is safe. Next slide, please. So these are some of the guiding documents. Many people are not familiar with water policy because they are so used to it coming out of the tap and being in good shape. But if you're interested, or if you're really into sustainability and you want to be an informed professional, you should really educate yourself on the middle two documents first. One is Legionellosis, the ASHRAE Standard 188. It is the guidance of risk management for water. It's based on Legionnaire's disease and Legionellosis, or Legionella in water. But the issue is that it will work for any pathogen. It's, again, because of the reportable disease structure in the United States, it's named after that. The other document to the right is the CDC's toolkit. I call it the playbook on easy, the how-to of how to do water management. Those two documents go together, and we use them as a teaching. I teach water management in various conferences and professional education. The bookend documents, one is from the CMS, which is the Center for Medicare and Medicaid Services, for those of you that might be in healthcare design. It's mandated by law now that if you want reimbursement in acute care hospital settings, you must have a water management program. You're not allowed to infect patients with waterborne pathogens. These same things exist over in the FGI guidelines on the other far right document, which guides us in how hospitals are to be constructed and protecting against waterborne pathogens. Next slide, please. So when you're commissioning for water quality, you need to understand there's methods to sampling plans, flushing, disinfection, and fixture cleaning methods that go on. And then those are sent off. A lot of times samples are taken and they are sent off. You either do microbial sampling to look for Legionella or other pathogens. We own 2 labs in the United States in addition to our services, and so we test many of our clients' water. And if you find discolored water or any of that lead issue or copper, if you have green water or murky black water coming out of these pipes, you have to do what's called a water chemistry analysis. And then all of this is reviewed by scientists like myself to assure that the building can have what I call a clean bill of health, and people can move back into the building safely and know that the water supply is secure. Next slide, please. Next slide. There we go. So the benefits of doing this is that obviously we want to reduce waterborne pathogen disease from something happening like that, but you also want to maintain a reliable source of water during an urgent response. One of the great things right now, without having a flood or a tornado or a compromised water supply, is that we're not dependent on bottled water. We can actually should be able to go in, wash our hands, shower. It's very important to have infection control, and you want to have confidence in the water supply. You want the people coming back to buildings to trust these buildings and trust the decisions that are being made. And the more transparent you can be about this testing and environmental sampling that goes along with the tracing of human sampling, which is what you've heard mostly about in the news, the more confidence people will have about going back to using their environments. This can protect healthcare workers or any occupant of the building. It also increases the building owner's defensibility. So this is often done for legal issues, and it helps people to understand whether these pathogens came from being on their campus or somebody else's campus. It's a real estate asset management process, and we do a lot of tracking of this through software because there's a huge amount of sampling that's done in these environments to keep track of it. Next slide, please. So next I'm going to talk about my participation on COVID-19 on the pandemic response and risk management. Next slide. So I got a call one day from some folks at the AIA National, and particularly Jane Frederick appointed me to work on a risk management process in which we would look at both healthcare surge capacity for the beds that you've all heard about, especially in New York early on in the pandemic, and then also what would be done with reoccupancy. I was asked to chair the first committee I was on, and then I was asked to be a public health expert on the second committees. These processes of risk management are used by our federal agencies under normal circumstances for other things, but they're also used during pandemic response and influenza response worldwide. On a more tactical level, some of you might understand that food service, water management, and then in healthcare design and construction, they use risk management processes. Every meal that you receive at a restaurant goes through a HACCP risk management process to ensure you don't get food poisoning. That's why we don't have food poisoning in the United States, is because of these risk management processes. But they're kind of going on behind the scenes, and the public really doesn't know about it unless they're in one of these industries. Next slide, please. So here's something I brought forward early on with the AIA work, is that we are in a pandemic influenza risk management response. Normally a country, or as we've seen around the world, most countries take this response. This is from the WHO pandemic information, where you have an interpandemic phase where you're notifying, you move to the alert phase, you're in the pandemic phase, and then you go to a transition phase, and then you go to your lessons learned. And in the United States, we seem to have decided to not take a uniform federal response. We've decided that this is going to be left to each state individually. And so when I was called by the AIA, we were actually in the alert phase, and I put we were here for now, and we are here supposedly in the transition stage. But if you look carefully, I've added an intercycle to this response, an outbreak cycle that will be trace, test, treat, isolate, and recover. Each state seems to be opening and closing and doing things of all these different parts. And so you're going to have continuous outbreak cycles of this disease structure because there was no uniform response. I'm not criticizing that, it's just a fact. Next slide, please. Also in response, I have to click one more time if we need a title here, or maybe it didn't come over. This is the WHO's, no, go back. Must not have got the title over. This is the WHO's guidelines for pandemic preparedness. It's called a whole of society response, this diagram. And so the yellow circles are the normal circles showed by the WHO around this, which is all the different sectors that you have to bring together in order to respond in a pandemic. The inner circles start to show how civil society will respond, business and government, and that this is a fluid situation. When I was reading these documents and I was talking to the team I had assembled at the AIA for the first part of the response, I said, I want you to note that shelter in the built environment is not mentioned, not 0, not 1%, not at all. It is not mentioned in these because it seems to be assumed that the built environment in its current state or with minor modifications will handle itself. I think we can see from the surge capacity and the response of the physical environment, that is a false statement. So I've added the bubble here of shelter, that the built environment response one of our callings here, as Illya said in the beginning, as an oath of ethics, is to go in and now inform this pandemic response and these national and international organizations that the built environment must be included in this response. Next slide, please. So with that, the first task force I was on for the surge capacity, if you're interested in reading about some of those slides that you saw before and get a more than this verbal explanation, there is a briefing document. It's relatively short about how to create an alternative care site, how it fits into this pandemic response. And our task force 1 authored that. The second document was, I call it the PAT V2. It had a version 1 and a version 2. It's a preparedness assessment tool. It's a checklist of what to look for surge capacity. So if, for instance, at the University of Arizona, they're thinking in bringing students back of setting up an infirmary. So an organization like that may want to look at this preparedness assessment tool and see what is it going to take to have an infirmary on campus. This document, we were validated by the US State Department, picked this document up and has distributed it and deployed it worldwide to all US embassies. And it has been translated into 3 languages. It's available in English, Spanish, French, and Portuguese. They wanted to do that. The languages that were selected first for the Southern Hemisphere, anticipating Brazil and Africa, are coming up next. The next tool that we did was the ArcMap. So if you're a healthcare architect and you had a COVID-19 experience with a client, you can go into the ArcMap and register your project. You don't have to register the building owner's name if there's a confidentiality issue, but you can put that up by state and you can help other people. We're recording this for historical sense, for research, and we're also just trying to be able to share examples across practitioners and across building owners. That's now going to be available also for those that are doing the Re-Occupancy. Next slide, please. So I was moved, and after the success of the first task force, we assembled a Re-Occupancy, and I was asked to just be a public health advisor. There are multiple documents coming out from this on the AIA website. Many of the concepts that Dr. Kevin and I have talked about today are in the public health briefing, the first document. So if you want to read about these concepts, I see some questions coming up about negative air pressure or what do these things mean. You can go to this public health document and you can read it. It's a briefing, it's not long, and you can understand those in more detail. There's a risk management plan, which I'm going to explain in a minute, but if you're a practitioner that's going to work with a building owner about how to move back in, and you need to do, they're going to do sampling and all these advanced scientific things, you may want to inform yourself about risk management teams and how you can be an effective advisor to that team. The third document is the actual Re-Occupancy tool itself. It mimics what we did for the surge capacity as a checklist, but it goes down through architectural and engineering controls, it goes through administrative policies you might want to consider, and it goes through PPE that may want to be considered for the project. Next slide, please. And again, the COVID-19 map is open, and you're supposed to be able to go in and pick different building types now that you're doing for the Re-Occupancy. Again, all of this is on the National AIA website. The COVID map was produced originally by the University of Kansas Health and Wellness and the College of Architecture with Frank Zilm and his team, and they stepped up and used a Power BI, so you can go down and pull down the building type and what you want to see. And this is now the 5th largest hit on the national website to be looking at. So these are tools that the AIA wanted to put out to its membership so that they know that this is here and to help practitioners nationwide and worldwide. Next slide, please. So I'm going to spend a few minutes giving you a mini lesson on some words you've heard today about hazard analysis and environmental controls and how that fits into risk management. And there's more of this, again, if you choose to use the AIA's website. So remember, this is the most common mistake by anyone who's involved in this, not just design professionals. A hazard is not a risk. A hazard is something that needs to be controlled. It is a thing. Risk is an evaluation. So if I'm driving my car down the street and there's a drunk driver next to me, somebody may decide that they want to continue driving on that same road and other people may not. That's a risk decision, and everyone will make a different decision. But the hazard itself is a physical drunk driver. The risk is whether anyone's going to continue to drive on the same road as the drunk driver, if that helps. So risk is a calculation of probability and severity. The more drunk the driver, the more severe the accident might be, right? So let's move on to something for the built environment. So when we define a hazard, it is either a hazard, potential hazard, or hazardous condition for a building function, in your case as a design professional. And if you click next on the slide, it is a physical, chemical, or microbial. This is what I deal with on a daily basis in classifying hazards. For your folks, you might want to add the word, write down psychological. We can have social science and psychological hazards in the built environment, but it's not something I deal with day to day as a water scientist. Next slide, please. So when we look at controls, so when we define a hazard, the CDC and all these organizations want to apply a control. That could be many different types of controls. So on the left of this diagram is the traditional ranking of what's called hierarchy of controls. At the top is elimination, and that is our charge as public health scientists to eliminate the hazard. You can substitute it. You can do something with what they call engineering controls. They don't call them architectural, which is a frustration I have. You can use admin controls or PPE, but you will see that the range on the far left side is the least effective is using PPE. The most effective is to eliminate. So if we look at this now in the context of the other triangle that starts with the gray box at the top, these type of hazards under COVID-19, we're really, elimination means either shelter in place or a vaccine. And the problem we're having with that, in public health language, it's called compliance fatigue. Society is tired of being sheltering in place. And so it wants to come out. It wants to do its social interaction. So substitution is not always applied here, but under the built environment, we're trying to look at social distancing, ventilation, physical barriers. So we're actually next up in that definition. Admin policies and PPE can be applied, but this built environment controls is being talked about and around and people sort of improvising, and that can be dangerous if you don't know what you're doing. The next slide, please. So what I did was, for the AIA, we took this risk management, I call it BERM, Built Environment Risk Management Program, and put it into a 7-step process that is used under HACCP for food and water and all these other risk management programs. And you can see the hierarchy of controls that I'm talking about is actually step 5 in the process. Analyzing the hazards, primary for us in this case is SARS-CoV-2, but we could have secondary hazards. If these buildings are modified and doors are removed, you could have life safety hazards, trip hazards, weather hazards, Legionella, bacteria, lead, copper, all these secondary hazards that could come into play. And how is everyone going to actually respond to that? But the problem I find is most people focus on box 4 and 5, and they forget the other steps of the risk management process. What we tried to do at the AIA was emphasize these built environmental controls in the Re-Occupancy toolkit that you can download. And we want you to use that toolkit, use the ARC map, and work with your clients through the risk management process to try to bring an interdisciplinary team so that you're not making decisions in a vacuum. Next slide, please. So I'm going to wrap up. This is something a little bit more technical, and it takes a lot more explanation. So I'm just going to quickly go through the 7 steps of risk management. You form an interdisciplinary team that, in my opinion, should include a professional, licensed professional from the built environment, including architects and engineers and maybe contractors. That team, along with the building owner and maybe health professionals, need to develop program goals. Set when is the building opening? Who are we going to be occupying in the first phase? Who are we going to be bringing back in the second phase? Then the 3rd step is to define that building and its functions. Where are people going to flow to? What's going to be open or closed potentially? Define the hazards, which we've talked a lot about, Dr. Kevin and myself, and then define the controls. But the thing that Dr. Kevin talked about that was so important is you must be able to verify that the hazards that you have analyzed and the controls that you have put in. So if you do all this 6-foot distancing of tables in a restaurant, who's going to re-put them back in position at the end of the day? Who's going to be responsible for that? That has to be verified every single day and throughout the day of operations. And the last step is you must do environmental sampling and human sampling. So if you put all these controls in and there's continual outbreaks in this space, what is the point? You must verify and validate the risk management process. Otherwise, you won't know how to adjust the controls to keep making them work and fine-tuning them throughout the process. So this is a known 7-step process. Again, not applied to the built environment. I'm writing a research paper on this model right now, hopefully to be published this summer. But this is now in the AIA Re-Occupancy documents as a guide, and I'm helping to get the word out that this exists and potentially consult with people on some of these types of things. So I will go quiet now and turn it over to our next speaker, I believe.
So here's your next word, folks in the audience, re-occupancy. Thank you, Molly. And this is going to bring up Susan. So Susan, we're ready for you.
Hi, everyone. I'm very happy to be here. I've been asked to participate in this panel to give some practical advice for architects, design professionals based on the science that Molly and Kevin have presented us with, which was fabulous. So now we've been given tools as well as scientific information, and how is this going to impact the architect's day-to-day practice? So these are some topics I will touch upon in my portion of the presentation, which are practical considerations and applications for design professionals. These are some of the practical considerations architects should be aware of, but certainly not all. And I'll go through each of these items in a little bit more detail. Next slide, thank you. So the first task for us all is to assemble the right project team. And we all should be realizing by this time that we've been faced with a different issue that becomes part of the design process for all of us, whether it's sustainable issues, acoustical issues, any kind of energy issues. Now we have health, care and specific issues addressing the pandemic and how it's affected our built environment and the people that inhabit it. So the first thing we need to do is consider your design team and pick people who have the right expertise you need to address your issue. And they could be consultants, specialized test agencies, or different collaborators with different skills. And then to speak to Molly's 7-step process for identifying risks and responding to them with design solutions, the risk management plan team should be multidisciplinary and should recommended to be including these types of folks: management, different engineering, architectural consultants, public health or infection control consultants, and others who are knowledgeable. Okay, next we're going to talk about identifying impact to the design process. So as I'm sure you're all aware, individuals vary in their risk tolerance. Some may agree to take steps to mitigate risk to obtain a safe outcome. Others are willing to take their chances and find the risk tolerable. This is the mask, no mask debate that's going on here. This may create difficulties in controlling the COVID-19 incidence rate and possible resurgence of the virus. Some of the reasons for underestimating risk are overconfidence in facilities, operations, and people, underestimating seriousness of the potential outcome, difficulty overcoming habits and/or a yearning to return to normal, lack of personal experience with severe cases of COVID-19. In other words, you don't believe it's really out there. Leadership demonstrating a high tolerance to risk, and expectations that if all fails, a vaccination will be discovered to change everything. And these are some examples of human behavior, compliance, and compliance fatigue, which play an important role when considering the perception of the risk of the virus transmission, and Molly discussed that. So the solution would be to break the routes of exposure through thoughtful design to minimize the reliance on voluntary behavior. And we see this happening now, promoting unidirectional workflow, designing for cleaning, minimizing potential for splash and touch, and optimizing opportunities to practice good hand hygiene. Next slide, please. Okay, I'm going to talk about a couple of topics in material selection considerations. As a specifier, I think about this quite quite a lot. And so I'd like to share some of this stuff with you. And so for the next several slides, you'll see some sources where I've taken information from. These are also included at the end of our presentation with links to the internet where you can find this information. So there's been research, published research, and that's the source at the bottom of this slide, that shows that the virus is more stable on smooth surfaces like plastic, glass, and stainless, and less stable on paper and copper. And the longest survival times are on stainless steel and plastic, which are quite a lot of materials in our built environment. So the design strategy for us should be to reduce the possibility of the virus transmission from frequently touched surfaces. So the solution would be to specify touchless fixtures and appliances to eliminate touch points. And these would be doors and door hardware, automatic openers, elevator buttons to be voice activated, for example. Drinking fountains could be eliminated, and we could put in automatic bottle fillers. And then, of course, faucet handles, toilet handles, soap dispensers, and hand dryers in the bathroom. Those are pretty common materials that we're all kind of aware of that are being used now, but for different reasons, for energy saving or, product safety or saving cost. Okay, next slide, please. Let's talk about antimicrobial treatments. I, as a specifier, get all kinds of articles sent to me about, COVID-19, use our antimicrobial doorknobs or levers. I would like to just let you all be aware of the fact that products that are considered furniture or an interior finish, including countertops and paints and hardware, may be coated or manufactured with one or more combination of antimicrobial agents. However, to date, there's no evidence demonstrating that products intended for use in the interior spaces that use these materials actually result in healthier populations. And further, antimicrobials may have negative impacts on people and the environment. For the widespread use of antimicrobials may be associated with microbial resistance to these agents and potentially to therapeutic antibiotics. And evidence is growing that antimicrobial additives can migrate from the products into the environment with unknown ecological implications, but with reasonable cause for concern. So next slide, please. And then of the utmost importance, the health claims made about the use of antimicrobial treatments to building materials and finishes can create a false sense of security that may cause building managers to be less diligent with cleaning and disinfecting protocols. They think something else is going to take care of it. They won't clean as thoroughly. So these are recommendations from the white paper at the source of the bottom of the slide. Until the CDC issues guidance as to the efficacy of antimicrobial building products, this white paper suggested design professionals avoid their use. And further, as new products enter the market, this white paper suggested the design professionals review direction from the CDCs and other local health authorities for direction on the use of these products. Okay, next slide. Impacts to building system design. This is addressing some of the science that Kevin presented. The ASHRAE white paper that's noted at the bottom of the page has specific design strategies relating to HVAC in medical and non-medical use buildings. It's a good document. And Kevin went over these with nice graphics, and mine are just words, but they have the same meaning. So the problem is the airborne transmission of the SARS-CoV-2 is sufficiently likely, as Kevin has told us, and operation of the HVAC system can reduce airborne exposures. An operation of HVAC can reduce the airborne concentration of the SARS-CoV-2 and thus the risk of transmission. So here are a few solution and design strategies. Making outdoor spaces, and you can read them. Enhanced filtration, they recommend filters from a MERV 8 to an upgraded MERV 13. UV treatments, as Kevin had mentioned. Indoor temperature and humidity controls, which he went over. And at making outdoor spaces readily available for use. All right, next page. Recommended proper filters for HVA systems and recommended intervals for replacement can be included in operation and maintenance manuals. We can recommend disinfectants that kill the virus on surfaces. And here's a website where you can go to inform yourself about different disinfectants and what viruses they eliminate and how they're applied, and what way you apply them. Can you go to the next slide, please? Okay, so here's an example, just a snippet from that EPA website. So you can see, and there's a lot of information there about if you're thinking of trying to kill the human coronavirus, you can pick from this Lysol brand all-purpose cleaner. It, in 2 minutes of contact time on hard non-porous surfaces, in healthcare institution and residential, it killed the virus. So this is a resource that you can all use if your owners are asking. Yeah, so these are readily available. You can look on the EPA website for the list of disinfectants. Next slide. Okay. So this is a new emerging concern for all of us. And we need to take the charge of protecting the health, safety, and welfare of the public as a most highly ranking concern for us. That's what we're licensed for. So now we have an opportunity to strengthen the knowledge that we have about person-to-person, air, water, surface, and fecal oral transmission in order to consider effective design solutions. And we can avail ourselves of continuing education seminars, specialized training, and I'm asking everyone to be aware of best practices, because best practices form the basis of our professional conduct. And it's very important that you are able to keep up with best practices. And I would recommend that you familiarize yourself with the AIA Re-Occupancy Assessment Tool, which Molly went over, the latest version. It's on version 2 right now. It has many suggestions for best practices that you can incorporate in all new buildings as well as buildings that are being reoccupied. So next slide, please. So this is just an excerpt from that document, and you can see it addresses different areas of the building, different parts of design, and it gives suggestions. So for space planning, reduce the density, increase the spacing of furniture, orient desks in all the same direction, reduce the amount of equipment to provide more spacing, remove lockers from corridors to provide a wider path. Some are very specific and some are very general. Non-structural partitions and openings, there's different recommendations here for touchless entry. There's signage recommendations. So these are all, really good recommendations that we could all learn from and incorporate in all of our designs to some extent. Next slide, please. Okay, so with everything else that's important, lessons learned from disasters or need for more energy conservation to mitigate climate change. These things get, eventually put in the code. And some of the items that I could envision that might be incorporated in future building codes might be adjusting the occupancy limits of a space, instituting enhanced building HVAC operational practices, instituting enhanced water quality management practices, require touchless operators or controls, additional signage, and additional entrances and exits to a building in order to make one-way passage. And I'd just like to stress, don't wait for code adoption. States are slow to adopt codes. Some of the states are still using the 2009 version of the code, and this will become part of the standard of care that we all are judged under. And as architects, we are licensed in order to protect the health, safety, and welfare of the public. Health, safety, and welfare of the public. If you're aware of something, you can't unknow it. You need to practice with the health, safety, and welfare of the public in mind. Okay, next slide, please. Right. So this is interesting. This is an article that I found in my local newspaper yesterday, and it really caught my eye, and I read it, and it kind of sums up everything I've been talking about. And I'm just going to read a couple of the excerpts from it. If you want to read the actual article, there's the link to it, which is also included at the end of the presentation. But in short, here's what it says. If office towers workers want to stay safe, elevator experts think they have advice, some practical, some not. Stay in your corner, face the walls, and carry toothpicks for pushing the buttons. Not only have these experts gone back to studying mathematical models for moving people, but they are also creating technology like ultraviolet light disinfection tools and voice-activated panels. So what they're talking about is the technology changes that we talked about, the physical barrier limitations, and elevator experts are recommending limiting the number of riders to 4 to accommodate social distancing. So this is a huge logistical challenge. If you're in a high rise, like a 90 floor building, and you've got hundreds or thousands of people riding, and they only are 4 in each cab, how are you going to move all those people? And so they're talking about different ways of doing this, calling the elevator via cell phone, lobby concierge run elevators, express services for each elevator. And in the past couple of months, it's been noted that certain companies have been formulating and selling ultraviolet light systems designed for elevators that are similar to those that are used to kill viruses for hospital instruments. And as of this article's writing, at least 100 buildings have signed up to install the technology. The owners, they say, are concerned about the liability of keeping up the long-term costs of keeping their cleaning regimens up to date, which is a valid concern. Okay, next slide, please. All right, so some takeaways from me, from my presentation, and that the design team, including the HVAC designers, should engage in an integrated design process in order to incorporate appropriate infection control, bundle in the early stages of design. Every building should have an emergency preparedness plan and a plan for an emergency response. While there is clear need for COVID-19 pandemic action plans, we must be cautious and inquisitive, follow the science, and ultimately provide building users with the necessary information to avoid a false sense of security. And the continual advancement of building design to promote equity, health, and well-being remains imperative. All right, next slide. Thank you. That concludes my presentation.
So here is word number 4 for everyone to get your credits for today. And while you guys are jotting that down, thank you, Sue, Molly, and Kevin. Well, wonderful presentations. Really, really appreciate not only your participation today, but the expertise and some of the work that you are currently doing in this realm. And it's quite a wonderful team that's been brought together. Here's our speaker contact information. And before we jump into the Q&A, there's a couple of things. Molly Babisi, who is on AI New York State staff, she is going to be posting a few things for everybody. And there's another thing that I'd like you to post, Molly. If you could post the Building Green article that I had sent out to you earlier today. It really starts to play into the first question I want to get back to our panelists. That really, Sue, in your presentation, you really opened up. It was some of the slides that you have really begin to talk about what may be some of the considerations, but how we imagine the future of not just of the industry and the built environment based on the information and the studies and the work that the three of you are currently engaged in. And so, Sue, I was hoping you'd expand upon that. If you could muse a little bit about where the building industry might be going from your standpoint, based on these new criteria that we are coming out in this disaster. And I do appreciate the fact that just as you've highlighted, after every moment, every disaster, every crisis, that does make itself gets into our building code eventually, but we have to be proactive about it as our ethical charge and our standard of care. So let me put this back to you, Sue, and then I'm going to follow up the same question back to you, Molly, and then to you, Kevin, to muse about where we are going in the built environment based on this information.
Yeah, so everything contains a risk and everything is a trade-off in the design process. As a spec writer, I have to work with the aesthetics that the design team wants to see in the building, their cost restrictions, the availability of materials, the suitability of certain materials for certain exposures or uses. Sometimes there's LEED requirements or sustainable requirements and acoustical requirements. And so there's a lot of trade-off that goes on when you design a building. And now this infectious control design parameters are being explained to us, and we're seeing in too much clarity what that means if we don't attend to those things. This is not the last time that we're going to be getting a pandemic, and we were woefully unprepared as practitioners of the built environment to address this. If some of these things had been addressed prior to the outbreak, then the outcome wouldn't have been as harsh. So I think, and Molly and Kevin, they're the scientific experts. I'm giving the practical response, but we need to be vigilant and decide how we're going to control what we can control in order for a better outcome for the users of our buildings and for the world. I mean, this is a worldwide situation, which brings us all together, and we have to be leaders at the table, and we have to make our voices heard. And I think I'm almost positive that that a lot of these recommendations are actually going to be woven into our everyday thought process. Things that are easy to attain, the low-reaching fruit, they'll be used. I mean, there's no reason why not to. But it's, as Molly, described in the risk analysis, you make choices on what you can achieve and what's the most important thing to achieve for your building and your team and your users. And it's going to be very fluid, but I firmly believe that these recommendations are going to be absorbed into everyday design for us.
That's great.
And they should be.
Thank you, Sue. Molly, what is your take on what this is going to mean for us and the AEC industry, or what buildings may look like?
Well, I like to put, there's been some folks that have said COVID-19 and its inflection point to me will actually bring great positive change. So I was, before I got my doctorate, I practiced and owned a practice in California as a healthcare architect. I designed hospitals for a living. Every single recommendation you are seeing here is already done inside of the built environment. None of this is new. It's just the pathogen is different. All of these techniques have been used in healthcare and are currently in the building code. Now, the emergency response of the social distancing and things, that has not. But the concepts of negative air and positive pressure and filtering air, now whether what we have currently works with this virus still has to be researched out. And that's a lot of what Dr. Kevin's doing. But I'm always flabbergasted to keep hearing, it's never happened before. This isn't in literature. That's a bunch of BS. When you look at research literature in public health, this particular virus might not be in there, but already there's thousands of articles on it. What you look up, if you want to look up the background on it, is a pandemic influenza response. If you look up and search those words, you will see thousands of articles in all, not necessarily the built environment, but in the response of humans. This has happened all over, this has happened before. It just hasn't come to the shores of the United States. I often don't like to use this comparison, particularly I'm here talking to New York citizens, but no one thought terrorism would come to the United States either, and that changed everybody's viewpoint. It had been going on in the rest of the world. It just hadn't come to our shores. and the response was totally different. So we need to get out of this concept that we're living in this bubble of it's not happening here. It's happening here. It's been happening here. Influenza and these unique things have been around in other countries and have, caused disease cases and terrible disease burden and death for decades and hundreds of years. We need to start raising ourselves up as a profession. So my hope in this, so for those of you that really get excited about these topics, I was a traditional healthcare architect and I sunset my practice and I went back to get a doctorate in public health. I'm an environmental health scientist. And instead of going and getting a master's in business administration, which people used to tell me when I became an architect, because architects were horrible business people, if those of you would like to be involved in public health, go get a certificate in public health. Sign up to get a master's in public health if you're young enough and want to do something like that. Go back and get a doctorate in public health, and you will be on the forefront of being able to develop these kind of solutions with the science in the built environment. So I'm making a call on all architects. I seem to be one of the few environmental health scientists that had a lengthy architectural career that brought that together. But I'm making a call on all our architects, healthcare and other architects, to collaborate together, as well as I want you to step forward and look into public health as a potential allied discipline for you to work with and or educate yourself within. And you're going to be the best practitioner you ever thought you could be to respond to this now and to respond to this in the future.
Molly, that's really great, and I really appreciate your take on this is going to trigger positive change. And
Right.
I wholeheartedly agree with you. Every time we have a crisis, it drives positive change. Right. Whether it was the Great Chicago Fire to you name it, it is a different challenge and it is a different hazard and it's a different response. But the positive change that could drive us to ways of working, habitual change, to all of these things are amazing. So I appreciate that. Kevin, what is your take on this? There's a lot of questions on the chat for all of you, but Kevin, what is your take? Could you muse about where this takes us for the built environment?
Sure. I think a lot of what's been said is really well put and won't repeat it, but I think there are some similarities, but there are also some differences to the previous influenza outbreak. I call this the 100-year flu, it seems. And the idea that there was a whole groundswell of kind of healthy building movement, access to light, access to air, that pandemic brought. And then various other pressures came in and memory faded, and energy kind of drove the narrative for innovation and design for most of my career until the last 5 years or so. And there's been this spark, this renewal for a focus on health in the built environment. And I feel like this just puts it into laser focus, the role of buildings to support human health, not just health and productivity and the economy, right? So buildings are the engine of the economy. And I think it's a tremendous opportunity for this profession to show leadership in creating spaces that are supportive of human health broadly speaking, human immune function in a sort of long-term exposure perspective, but also flexible and dynamic to handle acute concerns like a viral pandemic. And I think what we're going to see are buildings that need to be incredibly dynamic and flexible. I'm a proponent of advanced technologies, but at the same time, I'm a huge proponent of sort of basic natural systems and basic principles like natural ventilation and access to views and access to daylight. Those are the core really of creating healthy buildings. And then what's really wonderful is when there's a synergy where those basic principles of supporting healthy environments for people can also flex to reduce energy consumption and can flex to potentially minimize viral transmission. But I do think there is a place for technology, and so it's a layered approach. I heard a lot of people say, oh, this is the end of the open office, and I sure hope not, because open offices are places for collaboration and innovation. They allow access to daylight views and natural ventilation, and a lot of those strategies can be helpful in dealing with all these problems that we're describing. But there may be some hybrid layers for new technology, like a concept I'm calling personal airspaces. So this ability to, if needed, create fresh air zones right near people. And so this might be just an enhancement of things like displacement ventilation, but it could be more innovative than that. And then the other piece I'd say is any of these strategies need to be tested and validated, as Molly mentioned. And so this notion that you can now test your building and you can see if these design changes that we make in the long term or these operational practices that we enact in the short term are actually making a difference, and then which combination of those are really what's going to provide the safest indoor environment in this particular pandemic.
Great. So I do have a bunch of questions. I'm distilling this down, given our time, just to a couple of questions, and some of these overlap. So I'm going to put the 3 questions out there. I think, Kevin, the first one is for you. There's a combination of the second one for most of you, and then the last one, you guys can take it. The first one you already answered in the chat earlier on, Kevin, and I'm combining 2 questions. One is, how does humidity affect the virus? And could you comment on ionizing air filtration as you have studied? And the second question is for you, Molly. You had mentioned lead and water and unhealthy buildings. Could you expand on that so the audience gets it right about what you were intending? And then the third question is, now we have a lot of folks who are practicing, including myself, passive house design with air quality as it is from this virus. Are there some things that we need to discuss about that? So if, Kevin, you could take the first one about the ionizing filtration, and humidity would be great.
Sure, I'll try to be quick. So humidity can impact the risk of transmission in 3 ways. First is by more rapidly getting the particles that might contain virus out of the air. More humid air is heavier air, if you will, and the particles remain aerosolized for shorter periods of time and deposit more quickly. The second is that it can be a support to human immune function. And if you just think of this basically, if you're not dehydrated, your mucous membranes are likely to be more intact and therefore do the work that they're intended to do, which is including moving pathogens out of your airspace. And then the third is really, does it impact the inactivation rate of coronavirus? There's a lot of research on influenza. There's some research on previous SARS, and there's very little on the new coronavirus. But the general arc is that this mid-range humidity from 40 to 60% seems to more rapidly inactivate viruses. I don't have a great deal to comment on ionizing radiation. I haven't studied it in great detail. I will just say my concern with any technology is it proven, is it tested, ideally with a virus, ideally with this virus, and then what are the secondary ramifications? Are there concerns around indoor ozone generation? Because we need to make sure we're taking both the reason we're doing it and the secondary, perhaps unintended consequences into mind.
Thanks, Kevin. Molly, could you address the lead water? I think you've already started that in the chat.
Yeah, so I put up that phrase at the beginning. So as design professionals in a snapshot, there's a much bigger thing. So when water's delivered to your residence or to any building, it has what's called a disinfectant residual. Might be chlorine, it might be chloraminated, it can have different chemicals in it. So a lot of people push to have no chemicals in water. That's not possible. You won't be able to have water be safe if it doesn't have a mild chemical treatment. So what happens is that disinfectant residual is delivered to the building. Once it arrives at the building, if it is not used, it will dissipate and it will go to 0, and then it's unprotected and it begins to grow bacteria almost immediately. Then it can create biofilms in the piping. So what LEED encourages is to not use the water system, yet then the water system is designed for all this massive flow. And the differential between what it's designed for in case it's used versus people not using it for the flow, all these restriction devices, aerators, laminar flow devices, the lukewarm water, all these things that are in the system have not been designed for the safety of water. They've only been designed for the efficiency of water. So what happens, unfortunately, I'm one of these people in the United States where we have to go in and almost remove, if there's an emergency situation where people are being harmed, all that has to be removed from the building, reinstalled with different systems, and owners get very upset to spend that amount of money on an efficiency situation that's actually harming individuals in their building, and especially in healthcare. So we go back, because the technology, there's new systems coming out. A lot of things in water are coming out with new flow, auto, heating. So there's a whole things about heating and disinfection of water in order to be able to deliver safe water. And LEED is finally going to start addressing and putting some of these things in. But really, I would encourage everyone to read about water management. Both the well, Fitwell, other building systems are talking about this so that it can not have this impact. And if you're really if you're into sustainability and you're talking about these things with your clients, you would benefit from a course in water management. There's some online, I teach some professionally, etc. Not that it has to be for me or anything, but there's a variety of things you can look into to inform yourself about the chemistry of water on a basic level, so you're not repeating this offense of putting in low flow fixtures in the wrong areas.
Thank you. And then there's a question about passive house. So how do we does the passive house and the tightness of passive house, air exchange and circulation come into play with COVID virus in a negative way, a positive way, or what is the mitigation strategy in that case? Kevin, do you want to take that on?
Yeah, I'll jump in first. So
Sure.
What's interesting about passive house is really what it's trying to do is minimize the unintended infiltration, the unintended air exchange. And so in principle, that's okay, so long as there is an intentional ventilation strategy that can make up for it. We've done some research on not passive house per se, but homes that were before and after weatherization. And that's a similar process of tightening up your envelope. The homes that were weatherized had tighter envelopes, but also had intentional ventilation and showed microbial communities that looked more like the outdoors than the homes that were not weatherized. So that's actually counterintuitive. This was pre-coronavirus, so I can't say with as much assuredness, but I think the interesting idea is that you're separating heating and cooling from ventilating, which then allows you to manage energy and provide the amount of fresh air that's needed. I think the one concern would be oftentimes those dedicated outside air systems are undersized for some of what we're learning about the ideal ventilation exchange rates from either a human cognitive function standpoint or now from a needing to flex to higher outside air fractions. So I think perhaps the future of passive house would be similar to what it is, but with increased potential for outside air exchange through intention.
Thank you. Thanks a lot. So guys, we are at time and there's great information in the chat. As I said, Molly Babisi, this has been recorded and will be available. And then could you mention about the slides and then of course the housekeeping about the words that were out today?
Of course. Thank you for joining us, everyone. So there was 4 words that popped up, and hopefully you were able to take those words down. They will be needed to earn your 1.5 LU HSW credits. There has been a link placed in the chat for you to get that link and fill it out. Can you please have that back to me by midnight tonight so that I can get them submitted for you, and they should appear within your AIA account in 5 to 7 days. And I'll
Great.
send it again in the chat for you.
That's fantastic. And Molly, if you could please post that as we run into our last minute for at least that form, that would be great. And thank you everyone for participating. And I wanted to thank once again AI New York State staff and our 3 speakers. And so if everybody could clap online would be great for all these folks. Susan, Molly, and Kevin, thank you for your time today. Extraordinary work. We really appreciate it.
Thank you for having me. Thank you for having us.
Yeah, it was a pleasure. Nicely done.
Yes, thank you. I was very pleased to be participating with these esteemed colleagues.
Thanks, Sue. Thanks, everyone. Everyone have a great afternoon, and we'll be in touch.
Thank you.
Hello. Hello, is the, hello? Is the host still there?
Yes, William, what would you like?
Okay, you said you had to see 4 words to prove that you had been here. They
Yep.
came and went before I could note them.
Okay, they are in the chat again if you'd like to look at them. Do
I'm
you have,
sorry, say that again?
the words are in our chat box.
So how would I find those?
If you open up the chat on the bottom of your screen,
I think I have Zoom group chat, is that it?
yes, that should be it. If you scroll up a little bit, the CE words and the CE link.
Okay, hang on just a moment. I see, well, there are lots of, I see PDFs referred to. I see Yuki, great, you could make it, you know, I see lots of comments.
Okay,
see
I can tell you the
CE
words.
word.
I can
Yes.
tell you the CE words. They are microbial, bacteria, reoccupy,
Hang on just a moment,
or I'm
please.
sorry, reoccupancy.
Yeah, I just saw bacteria. So microbial, bacteria, reoccupancy, and
Disinfectants.
disinfectant. And now, what do we do with these?
So the CE link, that is also all the way at the bottom of the chat. If you scroll down all the way, it's the last
Hold
thing
on.
submitted. You're just gonna press that and fill that out for me. I'm
Okay,
also,
wait a minute. By the CE link, are you referring to where I can talk to you in the chat?
so in the chat, there is the hyperlink.
Oh, I see.
Go
Okay,
to the
so
form.
that's https forms.gle,
That's
etc.
it. Yep.
Okay, so if I hit that, I fill this out.
Yes, please.
I don't
Well,
get
thank you very much.
Where
Of
do I,
course.
this is Marvin also, where do I fill that out?
So do you have the chat open?
I have the chat open now, yeah.
Okay, perfect. I'm gonna send it in one last time
Where am I seeing this?
in the chat box. So at the bottom of your screen, there's a button that says chat. Go ahead
Yeah,
and open that up. If you scroll
right.
all the way down to the bottom of the chat, you're gonna see the hyperlink.
The bottom of the chat.
Yes, of the Zoom group.
I've got chat open. All I see is copy link, is that it?
Yep, this where it says CE link, and then there should be a hyperlink right under that. If you just click on it, it should take you to the form.
Wait a minute, I'm missing something here. I don't see a CE link and I don't see a chat link.
Okay. Can you give me your email address and I'll get it right over to you?
Would you please?
Yes.
MAISHE822@gmail.com.
Okay, let me just repeat it back to you. MAISHE822@gmail.com.
Right, now you're gonna give me the information and I'll fill it out and get it back to you, is that it?
Yes.
Okay,
Hello, hello.
Hi, how can I help you?
I've got all the words and everything, but I'm listening to you talk about the chat, and all I see is a black screen with some icons at the top, and it's the same screen I watched the presentation on, but I don't see anything at the bottom.
Okay, you can give me your email address as well, and I will send that to you.
Okay, it's V as in Victor, ECCHION.
Is this Francis?
Yeah,
Okay, I have your email address.
great.
Ready. I must have emailed you before.
Gary.
Yeah.
Perfect.
Hello, this is Gary Accord. I've got a question. I filled out the form. It asks
Yep.
for personal information, email address, name of the office, etc. It asks for my phone number.
Mhm.
I put my phone number in and all that, and I hit submit, and it comes back with an error code saying the phone number must be a number, but I've typed in my phone number. Oh, no spaces in between, I guess, huh?
Yeah, maybe just try to take those out for me and try again.
And then let me hit submit. And it looks AIA member number. Oh, I got to put that number in. Okay, I think I got it.
Gary,
Thank you.
was that Gary Accord there?
It is. Who's that?
Francis Vecchione, how are you?
Hi, Francis. How are you? Who the hell are you, Francis?
You've run into me before at Granary Associates and Mount
Oh,
Sinai.
yeah. Hey, Francis. How you doing?
I'm doing okay. How are you?
Well, we're all trying to hang in there with, we're trying to figure out how to, reoccupy Sloan Kettering after the pandemic. So,
Yeah, I was just talking to David Geller on email the other day. He's doing okay.
yeah. All right. Thank you, everyone.
All right, thank you.
All right, I'm going to suggest we play a game because we can't sit outside. So we'll have cocktails, a game, and dinner.